one of our faculty members, Dr. Stefano Bini. So Dr. Bini is the Maria Manetti Shrem Endowed Professor and is an arthroplasty surgeon, a hip and knee replacement surgeon here in our department. He's originally born in Italy, grew up in Australia, and then came to San Francisco in high school. Went to Stanford for undergrad, then Columbia for medical school. Did a fellowship at the Rizzoli Institute in Italy. And then he was at Kaiser for a number of years, including serving as the chief of orthopedics for their department before coming to us at UCSF in 2015. And since then, he has developed an active clinical practice. He's an expert in kinematic knee alignment, has a specific interest in gluteus medius repairs as well. And then one of his big interests is in digital orthopedics and digital healthcare, the application of technology to medicine. He has organized the DOCSF conference. He's representative on AUKUS, AOS, a number of national societies, really a pioneer in this digital transformation of musculoskeletal care, which is what he will be speaking to us about today. So Dr. Bini, thank you for doing this today and look forward to your talk.
Thank you, Drew. Outstanding. Thank you. This is a very exciting. Obviously, for those who know me, I live and breathe this stuff. I find it absolutely fascinating. It's a peek into the future. So I'll take you with a journey with me today on this topic. And let's get started. There are conflicts. I do consult several companies. This is various things. The only company I want to mention today, I'll show you a picture of the work they do. It's a UCSF company, Shrem Medical. Otherwise, nothing else should be a conflict. So this is our outline today. We're sort of talk about what digital orthopedics is, and I'll give you a whole set of examples. It will not be all inclusive, but I'll give you a sense of how far we've come in the last decade or so. Then I want to introduce a concept of confluence and show you where we might go with this, with these ideas coming together. I want to talk a little bit about why I think these changes will happen, the drivers of change. Introduce you to the concept of adjacencies, and then lead that into AI and the concept of innovation. And then talk a little bit about my most recent work, which is around sensors, which I think has the potential to truly revolutionize basically all of healthcare. I'm not being, it's a little bit hyperbolic, but it's interesting. All right, so 3D printing, we're all very familiar with. We know about bimodals, we know about instrument guides, we know about devices, spinal cages, things that could not actually be manufactured in any other way than through 3D printing, to the point where I'm just getting to do-it-yourself implants. I want to show you how far some people are taking this now. There's a hospital in Spain where they have an in-house 3D printing group that's got to the point where they're actually serving 20 separate medical specialties. Now, they got to the point where they actually obtained a license to manufacture medical devices. And then they built an in silico testing for biomechanical properties, which are approved by the EU, which got them to the point where they could partner with traditional vendors, obtain the licenses for the designs of their products, and print them in-house. So that's sort of the logical evolution of 3D printing. Our virtual reality, another technology that's really coming into the fore. You're all very familiar, I'm sure, with also VR. You can see the quality of the graphics, the ability to interplay between two different people within the same space is getting to be pretty phenomenal. And this is only going to get bigger and bigger as we start seeing the investments that have been made in the metaverse play out and give this technology a place to play, if you will. Augmented reality is becoming relatively mature in orthopedics. I have personally tried to place these pedicle screws into a model and found it remarkably easy. It's amazing how we can exactly see where your screw is going to go. In blind fashion, you can actually do this relatively well. Keep in mind that this person is looking straight at the spine. He's not looking at X-ray, not a CT scan, or an MRI. On the left, you see what a trauma surgeon might see with the vessels and the nerves projected into his field of view, as well as the fracture fragments. This already started to see in limb alignment, where in this case, the surgeon is seeing in his field of view the angles play out as he goes live. Instead of looking at a screen, he sees in his field of view. Holograms, this is the company I was referring to that I'm conflicted with, though, but I find this fascinating. What you're seeing is my iPhone and me holding a cube and manipulating that cube and actually being able to manipulate and visualize the defect in this bone that I'm gonna do an operation on. So rather than making a 3D model, which could be time-taking expensive, this technology allows you to do it very, very easy and very simply. Now, we've all seen this sort of technology, physical therapy, using avatars. This already is a way to move forward from video because you can change these parameters as much as you like. But where we're going now is the use of, again, gaming technology to have a patient holding, say, a device, moving their arm in space in exactly the direction you want while playing a game. So they're sort of distracted from the action and doing it that way. Another way that we're seeing physical therapy play out is the use of computer vision, which I'm transitioning into because it's a very hot topic right now. And computer vision can be used to track a patient's motion while they're doing the exercises and give them real-time feedback that very moment. No, your leg's not high enough. This could be used for yoga as well as it could be used. In my case, yoga would be very helpful. It'd be yelling at me the whole time. But also use it for AI and analytics. It's a company out of Stanford. You can see how it's tracking in lower left sponges, but you can actually see the detail you can see is a small needle. I mean, you can actually track these real time to help you be a little more accurate. And other companies are working on using computer vision to track you in surgery and actually break out your time sequence. If you're doing a total knee replacement, how long it takes to expose the knee, how long it takes you to prep the bone, and then tell you where your opportunities are to improve your times. Another area computer vision is coming is to an SPD near you, because now by virtue of the fact that it can track the instruments, know what instruments are, it can see actually good enough, well enough to see if they're damaged, pull them out of the set, replace them, find out what's missing, and also track them in the SPD. And so you know exactly where your trays are, and especially if it's tied to a robotic assembly system. Now, robotic surgery itself is also very mature in orthopedics. It's getting to the point now where somewhere in the neighborhood of 15% of all total knees are put in with some kind of robotic assistance. In the Australian registry, the partial uni is up to over 30%. Now with 5-year data showing that the results are actually better. But it's interesting, one of the bugaboos of robotics is that it requires a CT scan. It also requires you to go in and do the, what this gentleman is doing here, where he's identifying spots on the bone, about 20 of them, to let the robot know where the bone is in space. And there's some inaccuracy involved with this. Now there's technology, we heard from this company at DOCSF Venture this past week, which can use an optical scanner to obtain as many as 1 million data points from the surface of this bone in this case in less than 1 second. And it's so accurate that a very small surface area can allow it to reproduce an entire 3-dimensional model. Now the femur here on this, I think, rabbit is interesting. What I find fascinating is the spine one, because in this case, they've exposed a very, very small surface area of the lamina. And through that, they're able to reproduce the entire 3-dimensional model around that lamina. So you can see how you pair this either with the optical or with the augmented reality software I showed you earlier, and enables you to get some pretty phenomenal exposure, less surgery. Now, with respect to the CT scan, we're getting some really interesting companies, one of them out of Israel, that's able to take 2D images, so 2 X-rays taken at orthogonal views, and recreate a 3-dimensional model of that knee with about a 1 to 1.5 millimeter accuracy. That's only going to get better, but you can see that now if you can get 2 plain X-rays, give you a 3-dimensional model, you start to get away from the need for the complex and expensive CT scan. Next up is voice recognition and voice-enabled virtual scribes. Conversational AI and ambient computing are also terminologies that are discussed in this era. And what it is a device that sits and listens. Some of them have cameras attached. There's some security concerns there, but they can actually, that can be additional value proposition for some who are interested in it. They can actually sit in the room and listen to a conversation, parse out the parts from the patient, from the resident, and from the faculty, and actually create from that information an entire note. How close is it? It's about 75 to 80%. Today, these devices still need a human to go back and clean them up, but it does a good 70% of the work that is required for typing it up and decreases the overall potential cost. This technology is only getting better and better because these are neural networks that learn from what they see. And I think you're going to see a massive improvement in the next few years because Microsoft got into the game by purchasing Nuance. They started the deal in 2019. It closed about a month ago. They have a $10 billion investment in this company, and they're going to couple this voice recognition software to their AI in the cloud. And I think you're going to see a significant improvement. And it turns out UCSF does have a contract with them. And so hopefully we'll see this coming to our clinics near us to help us with our documentation. As you know, I'm very interested in surgical scheduling platforms, probably the lowest tech that I'm going to show you this morning, but some of the most powerful in terms of what it can actually deliver in terms of enabling us to be a little more efficient. We calculated that if we could fill 50% of available OR time in arthroplasty just by itself, forget the rest of the department, using the software because it has some search functions which allow us to find patients who are eligible to fit a slot that's currently empty, we could get something like a 15-to-1 return on investment. An area that you should be aware of is this is not AI, it's basic mathematics, it's complex mathematics, but it's basic mathematics. There are a lot of companies now collecting large data sets that are able to actually start doing things like this. Now, what you're seeing is the expected cost of a procedure, which is varies because of the patient population those particular surgeons are doing. So it actually has weighted averages. And the dots on the right are surgeons are way, way more expensive than expected. The surgeons with the green dots are the ones that are actually below cost. And of course, the rest in the middle. And you'll see this sort of technology play out pretty well in the context of insurance companies selecting who they want to do business with. Okay, moving away from the technologies themselves, all these technologies you've seen so far are technologies that are applied to a very specific thing. So whether it's a robot to do surgery. Now, you all use Uber. What you may not realize, there was actually no new technology involved. It was a series of technologies that are bundled together to create a new experience that wasn't there before. What would happen if we sort of did that in medicine? When you take multiple technologies and deliver a unique and new experience that was not previously possible. So let's look at telehealth and video visits. This guy looks eerily like Dr. Mohammed Diab, isn't it? Amazing. But the question is, the doctor will Zoom you now. And so a telehealth and video visit, you know, it's not taken off too well. There's orthopedic surgery at the bottom. In other areas of medicine, it did reasonably well. We did a study not long ago with Iliad looking at the adoption. Arthroplasty peaked during COVID and dropped back down to around 2 to 5%. So I would argue, though, the problem is not actually the concept telehealth, is that the technology itself isn't that good. I mean, this is not a wonderful platform that will replace the in-person visit. But what if, and let's follow me for a second. We took an avatar. Now, this is the latest version of this particular hyper-realistic humanoid. I want you to listen to what she has to say.
Thanks to years of research, we're making the leap from facial gestures to fully embodied gestural performance. I'll be able to use my whole body to communicate from head to toe. And all the while I'm serving brand new cinematic cuts that boost focus and direct attention. Best of all, it happens autonomously, in real time, without writing a single line of code. We're proud of how far we've come and excited to bring technology to life.
What she is doing is she's taking the feed from the camera on your laptop, reading your facial expression for mood, listening to your voice for intonation, and changing her facial expression to match that. You're upset, she'll be sad. You're happy, she'll be happy. She'll come closer if you need to be closer. She'll sit further away if she needs further away. Now, tie that in, to a chatbot. Now, chatbots are agents that can take information and give you an answer back. Now, in the beginning, in the old days, the information had to be given to the chatbot very specifically, and they used to ask you yes, no question answer, so it's Boolean. But now with natural language processing and other technology, it can take in questions taken in any which way you like and answer it. And it can look for the answer in the information that's provided to them from the clinic, from the hospital. Tag that, then add that to the physical therapies platform we showed earlier that can watch while you're doing your surgery, and then tie it into, say, Alexa. So these HIPAA-compliant virtual digital platforms that you may not realize today currently are locked into many healthcare systems, and they can contact their physician, they can schedule appointments, they can reorder medications, they can access and read hospital discharge instructions, right? So take that information, tied to the fact that now we have Amazon and UPS, both of which have won FAA approval for drone fleets and are operating them as airlines. So now you can actually do delivery. And you all at home have, I'm sure, some devices connected to another device. The Internet of Things is real. It's very much here. So what if all these technologies were connected? What could that look like? How could we take the telehealth visit to the next generation? So see if you can follow this.
Hello, this is Sol, Dr. Bini's assistant.
Hello, Sol. This is Tyler. I wanted to ask you about my recent surgery.
Hey, Tyler, I see that you had a total knee replacement 5 days ago with Dr. Bini. I have access to your records and can help you with any questions you may have.
Thank you, Sol. First, I don't remember what they found at surgery. I was a little out of it.
No worries. I just read your operative report and reviewed the visual records from the operating room. You had exposed bone on both sides of the joint and a torn meniscus. These are both considered excellent indications for surgery, so you can expect very good resolution of your symptoms.
That's great. The live XR was kind of cool. So I'm glad it was correct. Also, the drone delivery with my medications arrived just as I got home, but I can't remember which pills to take or when. Can you tell me?
Yes, of course. The discharge summary states that you should take the pain medicine about 20 minutes before you put on your headset for your virtual reality meditation therapy.
And my leg, it's a little swollen as well. Should I be concerned?
First, let's run a thermal scan.
You have my permission.
Thank you. Voice print activation enabled. According to the scan, the skin surface temperature and tensile grade is not suggestive of any complication of a clot in your leg.
Okay, well, that's super helpful, Sol. I feel much better.
Yes, I can see and hear that. Your anxiety measures dropped 7 points.
That's so cool how you can just see that. What else did you find?
You were a little behind on your knee flexion goals compared to other people your age and gender at this time in their recovery. You only achieved 100 degrees of knee flexion and are not putting enough weight on your operated leg.
Well, what do you think I should do about that?
I will send your results to Dr. Bini's office, as you might benefit from in-person physical therapy. I can arrange an automated insurance approval for the treatment.
Okay, well, that makes sense. You have my permission. In the meantime, what should I do for exercise?
Voice print activation enabled. I sent the referral request and it was approved. We can review the exercises you should be doing, and if you can put on your rehab sensor shoes, I can help verbally guide your exercises.
Well, I like the idea, Sol, but can we do it a little later?
Of course, I'll reach out at 7 a.m. tomorrow morning.
You're kidding me, right? I'm supposed to be resting, remember?
Okay, fine. How does 9 o'clock sound?
That's much better.
Great. I scanned your home and see that you have a connected coffee maker. I'll set coffee to brew at 8:45.
Well, thank you.
Right? I mean, she's available 24/7. She's never in a bad mood, doesn't take breaks. She can handle 5,000 appointments at the same time. What's there not to like, right? I mean, at some level, it's just it's taking work off our plate. So drivers of change. Let me just have somebody else put their perspective on it real quick.
The world is experiencing a surge in digital adoption like never before. Digital transformation that was projected to happen over the next 10 years is happening today. It is sweeping every country, every sector, and every organization. This transformation includes rapid advances in AI, which will have an enormous impact on augmenting human capability in healthcare and beyond. AI is technology's most important priority, and healthcare its most urgent application.
Chairman of Microsoft, arguably one of the most powerful and thoughtful people at the moment. It is really interesting, this idea of why should be so urgent in healthcare.
The world is
Now, this is a great model. Being able to touch your patients, hug your patients, interface with your patients is a great model, particularly for the generation in this picture that's accustomed to and expects it. But it's a very scarce and expensive resource. You have to keep in mind that the healthcare cost as a percent of GDP is rising every year. It's not showing any signs of abating. And for that amount of money, we're number 11 in the world in terms of the quality of care we deliver. The affordability on the patient side is ridiculous. People paying 30% of their income for care they can't access. And on top of that, if you look at the far right, this line here, the yellow line is a change in healthcare costs. The green line, the blue line below that, is the increase in people's revenue. So this is not, again, a particularly good model. And access to healthcare, something we talk a lot about here at UCSF. This is not evenly distributed. So it's costing a lot. People can't afford it. We're not delivering particularly good care. And on top of that, what care we do deliver is not well distributed. And on the back end of it, there's us. Physician burnout is at all-time high. And you could argue that part of it is the increase in explosion of medical knowledge. I don't know if you realize that we're talking about a doubling time of every 60 days at this point in the world's medical knowledge. How can we keep up? There's a lot of pressure to do the right thing when you don't know what the right thing is. I would argue the current model is simply not sustainable. It's not a matter whether it's good or bad. You want to have it as it is. It's just not something that we can continue to do. Now, I wrote a white paper I'm very proud of, 2017, which is the real question is not who's going to pay for tomorrow's care model. It is who's going to pay for today's care model tomorrow. It's a way to reframing the need for technology change. Now, there's also this question. 50% of the workforce today is a millennial. This side of the room, largely, is a millennial. Complete different perspective on what is and shouldn't be care models. And I can tell you that you get down to this generation and what we're offering today is not going to be something they're going to have much appetite for. So have we had massive revolutions in the past? Sure, of course we have. Keep this in mind. In 1800, food production was very complicated. 70% of the entire world's workforce lived on a farm. It was a very low productivity per capita, unequal distribution, very costly, low tech, back-breaking work. No one seemed to be particularly happy. That sounds familiar, right? And yet today, only less than 1% of the workforce delivers all the food in the world. And that's not well distributed, and that's a tragedy. But we do have an obesity epidemic. But so the flip side of this. And technologies are going much, much faster. It's not going to take 200 years like it did last time to get to the technology necessary. In fact, I've been arguing the whole morning that technology is here. We just have to embrace it. So how do you get to innovation? Because that's the key to making all this work. And I think it's worthwhile having a quick overview of something called the adjacencies or the adjacent possible. So it's an old idea, came out in 2011. It was older than that when it came out because it comes out of the evolutionary biology sciences. It's the idea that innovation happens in the realm of the adjacent possible and that the realm, which is the realm of possibilities available at any given moment. Such a powerful concept that TED this year is entirely focused on adjacencies. So the converse of that is that great ideas beyond the adjacent possible are doomed to be short-term failures. So obviously eBay without the internet doesn't work, but you could have conceived of it before the internet was available. But let's focus on the top picture. So there's a photograph of Dartmouth, and in 1956, a fellow called John McCarthy coined the term artificial intelligence, but it was just a theory. Today, it's a reality. What had to happen? The adjacencies required computing power. This is Moore's law on a graph. It's logarithmic. We've got doubling the number of transistors and integrated circuits every year, and it seems like it's never ended, but you can see the number of transistors now possible. So power of computing, we had that probably by the mid-90s. Then there's a cost of computing, because by mid-90s, computers are still very expensive, but today they've gone down to much, much cheaper. You always hear the story that what you have in your pocket is more than the Department of Defense had 20 years ago, right? But what was missing was massive data. And it really wasn't until 2002, 2003 that we started having data sets large enough to actually play out artificial intelligence. And then new chips had to be created by NVIDIA to make that happen. But today, and we presented this thanks to Nancy Lynch from Advisor Orthopedics, she works with us at DOCSF Venture. The investments in musculoskeletal care from the VC side, 75% include some, or in companies that had some level of artificial intelligence. So what is AI? So I just thought I'd take a crack at making it simple for everybody. So let's think about this context. This is a picture of an iris. Imagine a table with 150 pictures of irises, and you tell the computer, these are all irises. And you tell the computer to look for certain things, the length of the sepal and the width of the petal. And then for each photograph in that set, you show that this photograph that this picture has this number, this diameter sepal, this diameter pedal. If you then show it a picture it has never seen, it will know what to look for, and it will categorize that picture as a correct species of iris. All right, that's basic machine learning. Now it gets a little problematic if the number of variables or features gets to be complex, a number of types of images you're looking at vary, and you have to get into something called deep learning. Deep learning tries to mimic the way the human brain works. It's a class of machine learning algorithms that can learn from data that is unstructured. And a bunch of photographs, you don't tell it what it's looking at. You don't tell it that the sepals and the picture, the variation, where the variations are in the images. And so this is called unlabeled ground truth. So it's a way of looking at it is this one. So in machine learning, classic machine learning, you tell it that it's a blue car, you extract the features as a coder. So look for the shape of this car, look for two wheels, look for windows, and then it shown a different picture, it'll classify it. With deep learning, that part of it, the feature extraction, which is the most labor intensive and complicated part of all, goes away. And the software, if given enough good images, can then pick whether a picture is of a car or not, a cat or a dog. So given face recognition was the most popular one, the early ones of these neural networks that came out, given a lot of pictures of photographs, you can figure out that there are noses, there are eyes, and then start putting together and start looking for faces. Now, within the hierarchy of AI, it goes quite deep. And as you get past the basic training models of neural networks, there's convolutional neural networks. And just for fun, if this is fun, just get to understand when you see these terms, what they're used for and why there's a difference. So artificial neural networks are really good at solving complex problems like finding patterns. But it's not particularly good in video, which is a continuous sequential data input. For that, you need a convolutional neural network, which is great for computer vision. And behind that, you got recurrent neural networks, which are really good for natural language, where the answer may come at the end of the process. And one thing I have not talked about is clinical decision support, because it's interesting to me that over the years, this has been the nirvana. Everybody expects these software to come out and make diagnoses. This is actually the one area that it's least good at this point. Probably it's a data issue, but for the time being, we're getting to, even though it's a pretty decent business, just reading chest x-rays or reading pathology slides is about as good as it gets. And just yesterday or 2 days ago, there's an article in Nature really showcasing that a lot of these AI machine learning algorithms or neural networks, or even convolutional neural networks that go into these competitions, when taken out into the real world, only have about a 60 to 7% accuracy rate. So what is the near-term promise for artificial intelligence in musculoskeletal care? It's the basic, the stuff that isn't necessarily been developed for orthopedics, but will be accessible to all of us. This could be note charting. It could be reading and triaging your inbox. It could be billing. It'll help you track patients, help our patients take care of themselves, optimize workflows, and help us in surgery, including with robotics. Now, that means that at the end, this will allow us to do a transformation where doctors with AI will be happy with doctors without AI, largely because the artificial intelligence, the machine learning, the robots basically will take a lot of the menial work off our hands, take care of it well, and give us time to do that which only we can do. So now I transition a little bit to this concept of motion sensors and how powerful it can be if coupled to artificial intelligence. So I would argue that the goal of all of healthcare at the end of the day is to restore, maintain, or improve mobility, right? So basically, all the other specialties are in the service of orthopedics. We're all out to see if we can keep people moving. But we don't have a good way to measure mobility, right? It's actually quite interesting. If mobility becomes a vital sign, think about it as the end output of everything we do. Because again, at the end of the day, nobody is actually trying their hardest to get people to sit on the couch all day. Everyone's trying their hardest to walk and be actually moving. But we don't have a good way to measure it. There's really no mobility measure. The best we can do is a gait lab. And a gait lab with motion capture does give us the kind of feedback, the kind of data that allows us to truly see how a patient moves through space, especially around the knee and the ankle, but also the shoulder and the back. But it's expensive. It's limited in access. There aren't so many of them. It's very time consuming and it's highly constrained. because the information we get from the gait lab is only really applicable in the gait lab. We'd like to believe that it's applicable in the outside world, but we don't know that to be true. And it's also episodic. We only do that once, maybe do it twice, but we don't do it in everybody. And then we extrapolate it to everybody else. What if we could leverage the wearable motion sensor revolution, the quantified self movement? Because these are ubiquitous, they're inexpensive, they collect real world data when people are actually in their homes doing activities they normally do, and they do so continuously, something we've never had to work with. The problem is that they're neither accurate nor precise. For anybody who's worn multiple sensors at once, you get completely different data points, whether it's step count or whatever. Now let's see what happens when we actually do get really good data and it's accurate. You have a revolution. I mean, for those of you who have patients who have continuous glucose monitors, they've been completely freed. These devices track blood sugar every 2 minutes. They then allow the patient to microdose themselves tiny amounts of insulin when necessary and keep themselves euglycemic through the whole day, regardless of what happens. So we actually get away from this occasional checking of blood sugars, and the rest of the time, the sugars are all over the map. What would happen if we could do that in orthopedics? Tracking people real time, full time, and able to intervene at the right moment before they get the flexion contracture, before they lose their muscle strength, before they unload or overload their tibial fracture that you spent hours putting back together again. So 2 years ago, a year and a half ago, our team at UCSF with the Human Performance Center, myself and Anthony partnered with Google ATAP to test the hypothesis the machine learning algorithms could use data from inertial motion sensors to accurately replicate lab outputs that were known to be useful in measuring knee function. We specifically want to look at the knee. So essentially, you want to marry the gait lab and the wearable. Now, most people say, well, that's been done. Actually, it hasn't been done. Almost all the wearables, especially low-cost wearables that are out there, I'll give you the lower numbers down here, the speed, the stance time, stride length, the super simple measures to obtain. What they're not getting you is knee extensor moment, knee flexion moment, and so it's certainly not ground reaction forces. But those are the variables we need to truly describe motion. So we went to the lab, strapped on a bunch of sensors to a bunch of people, and started looking at the data. Now, this, I think, is one of the best examples of how to think about machine learning. So on the top, you have the data coming off a accelerometer. Below that is the data coming off a gyroscope. Each line represents a different axis. Below that is, I think, knee angular velocity. And the blue line is, the orange line is the gait lab output for that particular patient. And so we tell the software, in that noisy mess up there, find the pattern that matches that orange line and plot it. And it does so, and it makes the blue line with a 95.5% accuracy rate. You showed enough of these, and it can do the blue line without the orange line. And that's what we got to. We now are able to replicate the gait lab with a 98% accuracy rate across multiple different types of functions. And we're about to start the clinical data with actual patients. That means we truly have enabled taking the gait lab out of the gait lab, and for about $100, give you real-time, full-time, long-term data for the knee, eventually the back, eventually the spine, shoulder. What can you do if you have that? Well, knee angular velocity by itself isn't going to help you very much, but if you couple those variables with other variables, like continuous data output from multiple sensors or PROMs or SDH or demographics or genomics, et cetera, you put it all together, we're hoping to be able to come up with a sensor-derived outcome measure, one that actually creates an accurate, continuous, and precise picture of joint function, reference to the expected normal for that individual patient. That part is also not been done before because it requires a large normative data set that isn't biased. But the potential here is massive. Now, where else can you use it? Not just in looking at how you do the surgery, but device development, tracking the impact of pharmaceuticals, gaming, weightlessness in space. I mean, there's so much you can do when you can actually, for the first time, track motion in humans. But there's one more thing to borrow from this gentleman. The problem with the sensor revolution has been that even though we can do all the fancy AI on the right side of the slide, the raw data coming off the sensors has to be reliable. It has to be specific and sensitive. It has to be exactly what you want it to be to feed the algorithm, or you won't actually have an output that's accurate. The problem is that across the board, there are no standards for sensors. So we've set about creating those standards. As of the beginning of this year, we're working with the Consumer Technology Association and Google and a bunch of partners to create motion sensor mobility standards. If we can arrange that, and it might take a year, year and a half, and the manufacturers and the manufacturers of the sensors and those that are buying the sensors to put in their products start using sensors, then the data output from these sensors will be able to be used to create these algorithms. We're going to make the algorithm itself publicly accessible, along with all the data we use to train the algorithm so that others can follow suit. And we might be able to see the ability to collect clinically useful data of motion across any sensor that people are wearing and use it for clinical decision making. The potential for that is massive across all parts of healthcare. And I think if we can pull this off, particularly the standards, and then show what can be done with standards using the algorithms that will make it accessible, I think there's a possibility to start kicking off a really cool innovation in the world of musculoskeletal care. So we didn't cover a bunch of stuff because there's many other issues, and I thought I'd be late, but I'm actually a little early because I was obviously speaking too fast. But I do want to talk to you about this. For those of you who are interested in this space, as you know, we do host the world's premier digital orthopedics conference. It's called DOCSF. It'll be here in San Francisco. It's May 3rd, 4th, and 5th. And it will be pretty amazing. We'll also cover stuff I didn't cover today, like generative AI. You all been hearing about ChatGPT and what it can do. It has massive implications for healthcare, and it's worth will be worth the conversation. So we had a conversation today about digital orthopedics. I showed you a whole bunch of examples of areas where we're seeing innovation happening. It's no longer futuristic. It's no longer what if and when. It's happening today. I'll show you what will probably happen more and more of was people pull together various technologies to create experiences and software, experiences and technologies that we haven't had access to before, like that avatar that can follow your patients and manage them real time. We talked a little bit about adjacencies and how if you start thinking about what's possible next, adjacencies are an important thing to consider. Like, for example, a few years ago, people were talking about remote surgery. The adjacency that was missing with remote surgery was speed of data transmission because there was too much of a lag. About 3 months ago, no, 6 months, no, actually it was last year, a team in England was able to get to 176 terabytes per second data transmission speeds in the lab. That is the equivalent of transmitting the entire Netflix database in 1 second. And it's, I think, 18,000 times faster, 1,000, not 2x, not 3x, but what we have today. That we use at home. So that is also going to go away as a limiting factor. So as we start seeing the adjacencies come together, opportunities open up, and then keep an eye on the whole metaverse thing. It's not going to be just a game. And then we talked about the sensor evolution and our ability to start having real-time, accurate data transmission, accurate measurement of motion will allow us to start using that as an outcome measure in pretty much everything and start really discerning the difference between something like, say, kinematic alignment versus mechanical alignment, but it could be any other number of interventions that we have, whether pharmaceutical or surgical. And with that, I'm going to call it a day and thank you very much. And if you have one more second, this is a good sort of
smooth it.
Thank you, smoothie.
Calendar.
No meetings today. Remember, come later at 9:30.
Fire off.
Fire off.
Open door.
Door open. Så ska vi sätta en till.
Fire. Open door.
Wrong voice command.
Open door.
Wrong voice command.
Open. Open door.
Repeat that.
Open door.
I didn't understand that.
Hey, open door.
Play on the floor.
Get open door. Open the door. Open the door. Hey, with a rock.
So that's the easiest software in the office. So yeah, for those of you who are saying, hey, this is all very good and everything, yeah, it's true. There's some technology challenges of adoption. All right, with that, if there's any questions, I'd be happy to take them.
All right, thanks, Dr. Bini. There was a lot of exciting new technology, and looks like we have some hands up. Dr. Wostrak.
Thank you. That was really interesting and thought-provoking, and I love the video at the end. I think that spoke directly to me. But I had a question for you about the rising cost of healthcare, and if you have some data on that, because my uneducated understanding is that it's the adoption of expensive technology that's driving the rise in healthcare costs, like a total knee, now a total knee with robotics. How can a total knee with robotics be cheaper than a total knee without robotics? So I'd love you to explain to me how all of the technology will ultimately lower costs when it seems to be driving it.
So lots in that question, right? And that's just what I was trying to address that very directly with all the reasons why we have to move forward. The technology that's going to have the largest adoption is technology that solves problems in healthcare on access, quality, and cost. The first two are obvious because access is much. By the way, I took out a bunch of slides in here about what's happening in countries where healthcare now is at a pain point crisis. I'd say healthcare right now for us is a problem, but people are not like literally dying in the street, right? You go to China where only 20-30% of the population has any kind of insurance or access to healthcare. The virtual doctor, the Alibaba version of doctor is blowing up. They have tens and tens of millions of people on these platforms getting care. India, same environment, very low access, very little access to technology. You start making the kind of access that I showed you in the little video clip available to people that actually helps them answer questions and addresses issues. And it's enabled. In other words, you can actually start delivering entry-level healthcare. I think we'll be able to see the ability for us to deliver care in places we can't currently deliver it. I mean, the number of the challenges that are now, I'm sorry, let me rephrase that. Rural America, real problem, right? All the hospitals are closing. They're trying to stay open, they can't, largely because the cost of ICUs and any kind of clinical environment internally is too high. The way they're moving forward now is they're going to shut down all those hospitals and essentially turn them into emergency clinics, empowered with virtual VR and other telehealth services from large medical centers nearby that track what's going on with that patient and send helicopters out to bring them out as necessary, and actually send an ambulance out to pick up the patient if they need to be hospitalized. So those centers no longer become hospitals, and they centralize the complex care. That's happening today because those hospitals are all closing. They need to find something, they need to keep them open for access. That is all driven by technology, right? So the other area we're seeing a lot of technology innovation that's working well is resource reallocation. So there's a company down that came out of Stanford that can take all the MR data from say 8 months for an OR, redistribute block allocation, et cetera, very quickly by looking at data from the past, and can usually find between 5 and 10% extra space, which winds up being quite a bit for most hospitals, and continue to do that over and over again. What we're seeing technology be helpful with is resource reallocation. What you're talking about is top-end technological innovation that may not actually have a proven benefit. Now, robotics is controversial. Robotic surgery and knee replacement, though, is very well studied. Now, you're looking at whether you're using state-level data, Medicare-level data. If you look at readmission rate, complication rate, infection rate, et cetera, in robotic surgery is consistently lower across the board, no matter who looks at it, no matter how disinterested or interested they are in the outcome. It does decrease the variability in the outcome. The cost, we have internal data here locally. I started robotic surgery a year and a half ago. The finance office wanted to see how it was going. We're actually cheaper with those cases than I am when we are with the other competitive implants here in the hospital. So believe it or not, the cost compared to, it doesn't have to be necessarily higher for some of these technologies. There is a device you can put on a spine that actually guides the needle. So you can do a spinal in about 30 seconds, 95% accuracy rate. That's a cost, but I would imagine that I would think that would be an additional cost that would actually be cost effective, right? Because it wouldn't slow down our OR times. So to me, the technology, if there's technology out there that costs, like for example, Nuance we'll hear about, that's not inexpensive to have a Nuance contract for UCSF. But once you'll see it and you start using it, I think you'll choose not to live without it, because having that documentation done for you will be very helpful. So to me, it's like, yeah, but we're spending money well if we're providing better access and better quality outcomes.
So we'll go to Dr.
By the
Bailey.
way,
and then-
pharmacy is really the one that's driving the most of the cost in the hospitals.
So Dr. Bailey, and then I see Dr. Emmerman's hand up next.
This is kind of along the same line of the previous question, but I believe in digital technology. It's coming. But if we think about physician burnout and adopting all these efficiency technologies into the clinic, I feel like it's kind of like bringing email to us, which we're drowning in, and it's contributed to burnout, or Zoom, which like saved us during the pandemic, but also definitely contributing to burnout. Like how, while it's great, I think there needs to be like a plan to control some of the, efficiency modalities that are planning to be rolled out into clinic, because otherwise you're just going to have more patients and then richer content to look at that will probably be exhausting.
That's a fair point. Yeah, from that perspective, look, do you enjoy, it's not even you, it's your staff is currently picking up a bunch of calls about rebooking appointments and questions about that medication you ordered and when the next chemotherapy round is, and do you need to have those conversations? Are those regenerating? Or could those people be used to do work that's a little more productive? Do you need to have that conversation 3 times for the person who has a little bit of forgetfulness? I mean, the question isn't how to take away your higher level functions. It's how to take away those functions that are repetitive, which could be coding in your chart, for example, so you don't have to do it. I think that perspective I'm not so much in agreement with, but I do think Jeannie's right, because there is a potential, of course, that if you make people more efficient by taking away those things just simple and stack them up with things that are difficult, that is not necessarily a positive outcome.
See, Dr. Emmerman.
Sure, thanks, Stefano. Really amazing stuff. And I mean, there's so much new technology being developed. But one of the things that I also see is each company, as they develop a new technology, are also trying to, in their effort to monetize it, build up a barrier in some sort of way to, they have a patent, etc. So, great examples would be, let's say, scheduling software. You could have the best scheduling software, but at the same time, that software can't interface with where we live in our daily lives, which is like, for example, Epic or Microsoft Outlook, because each of those companies is interested in selling you their own software. And you can have the best EMR system, but it can't talk to our EMR system, so we can't even learn about it. We can't adopt it. What do you think, or what is happening on the legislative level or other levels to try to create open standards that will allow us to really use new technology in our daily lives, software or hardware, like
So
to allow them to talk to each other.
Right. So interoperability, right? The question is, where are we in interoperability? Yeah. So interoperability has made several leap forwards with the advent of something called the Smart on Fire APIs, which allow simplistic or simpler conversations between software, if you will, and connecting them. There's also been government legislation that went into play last year that requires and forces electronic health record companies like Epic to actually allow patients to have access to the data and transition it take it from one place to the other, and also share it. But you're right, those companies don't have a vested interest in sharing that information. But it turns out that after those laws went into effect and the data sharing process was much facilitated, it was the hospitals that started to make it difficult for patients to take their data because they don't want to lose them to another hospital. So you're right that there's in a competitive environment, a capitalist environment, the incentives to not share or not create sharing platforms are very, very strong. So I'm not saying I have an answer for you, but there's definitely governments that are working on that. In the EU, it's definitely a lot easier because you've got the European Union that is taking a far harsher stance, both around privacy, but also on data sharing, and they're working in that space as well. There are groups that are creating open standards, like we're going to try to do with this sensor work, and publish the algorithms so they're consistent, and we will see some improvement in this space. That said, it has been a huge issue for the last decade. I agree with you completely. I think we'd be much further along if the APIs were more open earlier, especially on the health record. Because I told you earlier that the AI is a little behind in healthcare. It hasn't gotten to the point where it can actually do predictive analytics yet. Really, as far as I'm concerned, that its diagnostics isn't that strong yet. And part of the reason is there are very, very few large data sets that we can train these algorithms on. And they're specific to specific countries. Like I think it was Holland that's released a large data set, but it's kind of Dutch centric. We can't take that data on those algorithms unless you retrain them on a large data set in the United States and make them not have bias. So it's kind of complicated.
All right.
Thank you.
Dr. Wiggins.
Morning, Dr. Bini. Thank you for the talk. I wanted to circle back on this idea of access and how advancing technologies may be improving access for patients that otherwise wouldn't have it. Do you believe that that goal is actually being achieved with these advancing technologies and avatar services and so on, as opposed to just altering the experience for those who already have access to these things? Are we actually closing that gap or helping those underserved or underrepresented people access healthcare in any different way?
So I think what you're pointing to is the potential for what's being called a digital gap. That is driven not just by access to healthcare, but access to digital technologies, right? You're actually seeing hospitals in some highly constrained areas handing patients cell phones with plans so they can actually access these services online. I don't have data for you, so I'm going to just make it up, but there is I don't know how many tens of millions of dollars, a big industry now, with on-demand physicians. So people who, this is particularly popular with pediatrics because often young families don't have insurance. We can basically dial up a pediatrician, have a conversation real time. And those companies are blowing up because of the access gap that we talked about. A lot of people aren't insured or underinsured, don't want to spend the $300 co-pay to go see a pediatrician. They can just dial one up and they're very, very good. They've selected physicians from some of the best hospitals in the country, and they can deliver great care. I've seen a company now that has developed a concept where they've actually created these booths. You walk in the booth, and in the booth, there's a bunch of tools. And there's a very low-level, entry-level trainee in the room that says, okay, this is how you put a stethoscope on, this is how you put a blood pressure cuff on. And then on the screen is a physician who handles the visit. Very low cost, very entry-level. All this is happening. Then you've got the whole retail health side, so Walmart, CVS, that are creating the minute clinics for basic stuff. Where we're still having issues is one level above that, right? Partly because given current laws, this software can't actually practice medicine. It actually can't tell you take a Tylenol, it's okay, go away. Go home. Will there be a digital divide going forward? There's always been a divide in this country. I don't see that going away. I think it's part of the capitalist system. I think you'll see less of it in Europe, but and in emerging countries, you're seeing what I was talking about earlier in China, where it's either no care or digital care, and digital care is better than no care. So I think it's a step forward. Should they get better care than that? Should our folks living in remote areas 50, 60 miles from a hospital have the right, they're paying taxes too, to have actually better care? Yeah, but that's just not the way our country is structured.
Thank you.
And then we have a comment from Dr. Rose, or question. Do you think the mega companies in today's healthcare have the ability to embrace innovation through confluence, or is this a startup thought process?
The way the mega companies are embracing innovation in 2023 is to acquire it. So what you're seeing is you're seeing companies like Microsoft buying technologies that have been de-risked to some extent and implemented and have been shown to be successful. And then they're definitely aggregating them into larger components, but usually as part of their other services. So Confluence almost at Microsoft is almost by definition what they do. Have they had some hit misses? Well, yes, but I wouldn't rule them out. I mean, with their acquisition of OpenAI that just happened. So they're gonna have ChatGPT. They're gonna have this. They're gonna have Nuance. They have the cloud, which is Azure, which is one of the biggest clouds in the world, and they're in almost every hospital because almost every hospital is on some form of Windows and platform. Their ability to leverage their technology to support healthcare, which is massive, it's what 1/5 of the U.S. economy, is going to make them increasingly powerful, and may give Google a run for their money when it comes to some of the next gen innovation, especially search. Because if you imagine coupling ChatGPT, OpenAI with search, that starts to get pretty interesting.
All right, and I think one last question from Dr. Casalino.
Thank you so much, Dr. Bini. That was an awesome talk.
Thanks.
We saw the work you're doing with the sensors, and then I love the beginning part of your talk where you talked about all of these different companies that are providing all these different innovations. Are there sort of like feet on the ground plans for implementing those into UCSF? Like, what can we expect moving forward here at UCSF, sort of rather than just like everything that's going on in the industry?
So UCSF has a strong history of innovation. It was largely driven through Center for Digital Health Innovation. There's been a bit of reorg recently with our new leadership, and I think I've spoken to our new CEO, and I know he has a very strong interest in driving technology and creating an environment where it can be a little easier to do so. For me as CTO, it's been quite challenging because the biggest issue was that we worked through Epic, and even though Epic has actually made accessing the platform a little easier through their Orchard and the implementation of these Smart on Fire APIs, which most companies can tap into, access to Epic has been very much curtailed. And if I can't access Epic, it's really, really difficult to put in place any technology that's helpful. We've sort of hacked our way in with our digital scheduling platform, but it would be an awful lot easier if we're able to test it with a version with an access point. So, and that is all around the question of cybersecurity and security and access to these healthcare data. So just very briefly, what you're going to see next, I think in the evolution of this whole place, is that the health record becomes a repository of information. Between the health record and the apps, there'll be something called middleware. Think of it as the OS or the operating system for healthcare, which all the apps can plug into, and then it creates a barrier, if you will, a security barrier to the data set that actually resides in the health record. And we will work in this middle space, interfacing with the apps and plug and play. And just like your phone, you got a dozen of them, but somebody else has a different set, collecting data and presenting the information you needed today. So I think that's going to happen. Right now, it's a little challenging. But if you're looking at a time frame of your practice, yeah, no question, you can see all this stuff accessible to you. It's just a matter of solving the security equation. I think it's the last barrier. So with that, I want to thank everybody. Thank you for listening.
Right. Thank you, Dr.
Good questions. Thank you.